with you. We will follow the board guidelines. CBSE board given some guideline in their syllabus only, code 241, as they have mentioned for this year's syllabus on indefinite integration. Will be going according to this. Before we see the syllabus for indefinite integration, let us go through the aim and objective as written by CBSE for applied mathematics students of class 12, code 241. The concept of integration is widely used in business and economics. Some of them are as follows: marginal and total revenue, cost and profit, capital accumulation over a specified period of time, consumer and producer surplus. So this is application part. Before you are going to apply to solve problems on marginal cost, marginal revenue, capital accumulation, consumer producer surplus, all these things, you need to know some concept of the indefinite integration, which actually follows from the process of differentiation only, which we will see as reverse process of differentiation. All of you have seen this and you are practicing from various textbooks like M.L. Agarwal, R.D. Sharma, some other books also there, practicing question papers. But some of you might not be doing the NCERT support material which they have given. Today's class will be based on NCERT support material, because before your board examination, you must know what is the aim and objective of this applied mathematics integration, this portion, and what is expected from you. You don't need very difficult integration. The integration which is required for core mathematics, biology, trigonometry, all these things, many formula there. Here, specific formula there, we will be working on it. We will find mainly application in practical, solving practical problems. But it is not true that indefinite integration in your course, it is given just to solve practical problem. Some core concept of integration is required there, which will follow from the concept that integration, indefinite integration, is the reverse process of differentiation. Before we start revising it from the CBSE syllabus, let us go through what is mentioned in applied mathematics class 12 syllabus, that in integration and its application portion. You can see that integration, that initially it is given, understand and determine indefinite integration of simple functions as antiderivative. So first part of our discussion will be on this, where we will see that indefinite integration as the reverse process of differentiation. It is antiderivative. Integration, what is the learning outcome from there? Integration as reverse process of differentiation, you will come to know vocabulary, notations related to integration, all these things you will come to know. And then indefinite integration as family of curves. Whatever you get after using the process of antiderivative, that actually represent a family of curves. That I will also explain. And learning outcome from here, simple integrals based on each method, non-trigonometric functions. They are mentioned clearly, no trigonometric function there. And then definite integration as area under the curve, definite integration and application of definite integration is also there in many problems, and then comes differential equation. But here in today's session, we will be discussing differentiation as reverse process of differentiation. At the same time, we will evaluate indefinite integration by simple algebraic functions by method of substitution, partial fraction and by parts. Mainly these three topics are there in CBSE class 12 applied mathematics syllabus. But this part, when you are using by parts formula, there are I better say there are two types of formula. One formula is for just how to integrate by using by parts, and next one some standard integrals based on it. Let me discuss one by one in indefinite integration what you can do before your board examination. So initially we just see this one as the integration as reverse process of differentiation, and there in reverse process of differentiation derivative you know and corresponding integral you have to write, because derivative of this thing is x to the power n. So x to the power n derivative is, integration is this. This is the symbol used for integration where n not equal to -1. And what is derivative of x? For x, when you consider it is x to the power 1, so 1x to the power 1, that is equal to 1 only after differentiation. So integration of 1 dx or simply integration of dx is equal to x plus c. Integration of e to the power x, because derivative is e to the power x only, it will be e to the power x plus c, and a to the power x dx integration by the same manner, it will be a to the power x by log e. This formula, when you are not taking n equal to -1, what will happen for n equal to -1? For n equal to -1, we will remember the derivative of log x. Derivative of log x is 1 by x, and log x is undefined for x less than 0. That's why the formula will be writing here log of mod x plus c. For x greater than 0, its derivative is 1 by x. For x less than 0 also same thing, that is d dx of log of -x, its derivative 1 by -x minus 1, so it is 1 by x. Your class 12 indefinite integration mainly runs on these 5 formula, 1, 2, 3, 4, and this is 5. Very easy to remember. So let us see how to apply this formula to solve integration by using substitution method. Okay. Sometimes you need not use substitution, sometimes you need to use substitution. We will solve those kind of sums. Before that, some standard integral part also I would like to revise with you. What are the formula there? I have taken all the formula from NCERT books only, NCERT support material only. The formula given this manner, dx by root over x square plus a square log of x plus this, and for minus a square, just a square will be changed to minus a square. All of you know this very well. Root over x square plus a square. This I wanted to say, these are the formula we use after by parts. But here NCERT people have listed in the formula list root over x square plus a square. So you just revise it here only and then apply in solving sums. X by 2 root over x square plus a square by 2 log of root over x square plus a square. If minus sign is there before a square, there will be minus sign. Okay. Then 1 by x square minus a square dx, half log of x minus a by x. See, x minus a get preference, it goes to numerator. I remember this manner. And for a plus x, a minus x factor, a minus x will go to the denominator. Okay. And for next one, that if 1 by a square minus x square, that I have explained, root over a square minus x square is there, this formula you don't need. Okay. So although it is mentioned in your NCERT book, NCERT support material, you don't need this formula. When no trigonometric function can be given, sums cannot be asked on indefinite integration, which is of the form root over a square minus x square. At the same time, I like to say that dx by, you don't have to worry that this form is also not there, dx by under root a square minus x square. Okay, it will never be asked in board exam because the formula you need here, which is another trigonometric function, inverse trigonometric function, not included in your syllabus. Okay, so we are going to use mainly these 6 standard integrals and this basic formula for integration, that integration of x to the power n, integration of e to the power x, a to the power x, and x to the power n in 2 cases when n equal to 0, that is only for dx, and for n equal to -1. Clear? All of you understand what you are going to do, what you are going to expect in your board paper. Sums will be exclusively based on these 5 formula and these 6 standard integrals. Okay? No other formula, no other integration method is required. Now, before we start our revision work, I would like to remind you this thing, that when you are integrating an indefinite integration portion, that will give us a function plus a constant. A constant always should be there. Okay. And if it is fx plus gx, sum of two functions, it will be integration of fx plus integration of gx. For three functions, what to do? The same manner, fx plus gx plus hx is there. Then its integration going to be equal to integration of fx dx plus integration of gx dx plus integration of hx dx. So this thing can be used for any number of functions, and if it is multiplied by a constant k, then k will come outside, it will be k into fx dx. Okay. So those 5 formula, these 6 standard integral, and these basically 2 methods, 2 properties. Okay. 2 rules of integration will help you to do all the sums from indefinite integration, which is going to be asked in your board examination. Okay. So in part 1, I would like to discuss integration by substitution. Okay. And we will follow the board guideline. Whatever they are given in their support material will go accordingly. Okay. When you are going through this exercise in NCERT support material, that exercise 3.1, all these kind of sums you have already done. I just remind you 1 or 2, 3 sums from here, because there you can see that this is x plus 1 by x whole square dx. You don't go for substitution blindly, just ordinary method is useful over there. Okay, you just open the bracket, it is x square 2x into 1 by x plus 1 by x square dx. You know, so after integration it will be x square dx, 2 will come outside dx plus x to the power minus 2 dx. So on integration it will give us x cubed by 3 plus 2x, x to the power minus 2 plus 1 by minus 2 plus 1 plus c. Plus c must be there, because when you are integrated you will get a family of curves. This is actually y. No, if you take this one as y, then y is this. This will represent a family of curves. This curve can integrate your cost function, that revenue function, marginal cost function, whatever. But it is a function, remember, it is a function of x. Even when you are doing this sum, you just open the bracket and integrate term by term. But how to do this one? This one is very easy. You just factorize from numerator. This will give us x plus 1, x square plus 1 by x plus 1 dx. Cancel the factor and then integrate term by term. Okay. Number 5 also you will be doing without substitution. You just open the bracket and then integrate term by term. But when you are doing number 4 and 6, then I have some suggestion for you. You can go by substitution or you can't go by substitution. It's up to you. Some people, they are very smart, they remember that the formula for this thing. There is no problem if you can remember this one as additional formula. Ax plus b to the power n dx is nothing but ax plus b to the power n plus 1 by n plus 1 into a. It is done. So when you are doing 3x plus 5 to the power, root, so it will be half dx. The answer is 3x plus 5 to the power half plus 1 by half plus 1 into 3. This plus c. So it is finished. But if you want to substitute, then you will do definitely by substitution. Also it can be done. Just I am showing you how to get this sum by substitution. For number 4, again by alternative method, you make a substitution 3x plus 5 equal to z square. So it will give us 3 dx equal to 2z dz. So dx equal to 2z dz by 3 So I is going to be equal to root over z square, it will give us z only. Dx is 2z by 3 dz. So answer is 2/3 z square dz. So the value of this integrand going to be 2 by 3 z cube by 3 plus c. So answer is 2 by 9 z cube plus c. It is 2 by 9 z cube. How to get? You get z from here. This implies z is equal to 3x plus 5 to the power half. So this is 3x plus 5 to the power half. This plus c is the answer. Okay. So by substitution can be done, and by using the formula what you got there, by this also it can be done. Number 6, you will rationalize, and I will suggest you to use this formula, ax plus b to the power n plus 1 by n plus 1 into a. Okay, can be done by using the formula also. Now let us see the next type of sums where substitution is essential. Without substitution you won't get. And most of the sums, when something is there in under root form, you put that is equal to z. When something is given in denominator whose derivative is numerator, you put the denominator equal to z. You can find many sums over there. For this sum, you can see the derivative of this is not exactly the numerator, but you can get it easily from there. ddx of x square plus e to the power 2x is nothing but 2x plus 2e to the power 2x. If you take 2 as common, it will be x plus e to the power 2x. Alright. So for this sum, it will be enough to substitute, put x square plus e to the power 2x equal to z. So if you differentiate 2 into x plus e to the power 2x dx is going to be equal to dz. So x plus e to the power 2x dx will be dz by 2. So I is equal to what? dz by 2z. Its integration you know, half log of mod z. Input the value of z there, it is done. And for this sum also, if you put 1 plus x e to the power x equal to z, its derivative will be the numerator. You can get dz by z square form, you can integrate. For this sum, derivative of this thing will never be this. We have to use special method for this. But for this one, you will put x square plus 1 equal to z or z cube, whatever. You put z cube or z, it doesn't matter. And for this one, put x equal to z square. Okay. For this one, you can see the derivative of a to the power x plus x to the power a equal to a to the power x log a plus a x to the power a minus 1. So if you are taking a as common, this is going to be a to the power x minus 1 log a plus x to the power a minus 1. Alright. So it is going to be of the form dz by z. So answer is log z. Alright. So sum can be done by substitution, most of it. But this one can give you trouble. Try by putting the denominator equal to z if it works. And these are on standard integral. You can get it easily. I am just showing you number 3 here, that when it is 1 minus 2x by under root 1 plus x square dx, you write this one as sum of two integrands dx by under root 1 plus x square minus 2x dx by root 1 plus x square. For this one, it is a standard integral, you know it is log form, log of x plus under root 1 plus x square. This minus, how to do this one? Make a substitution, 1 plus x square equal to z, 2x dx dz. So it is going to be of the form dz by root z. 1 by root z is z to the power minus half. Integration is so easy there. So most of the sums can be done by substitution or by standard integral. 3 part 2, you need to use standard integral formula over there. Okay, let me do that. Let me remind you this, better to say, because you have practiced from many other books, but in support material you might not have started. For this one, you can convert this one to standard integral. I am not telling you that you do NCERT material only. You do from other books, variety of sums are there. It will help you to understand the sum given in the exam, but you don't ignore the kind of sum given here. It will help you what is there in the syllabus. How to integrate this one? You need to change this one into standard integral. You go by method of completing square here. Take 3 as common. It will be x square plus 2 by 3x minus 1/3. This is nothing but x square 2x into 1 by 3 plus 1 by 9 minus 1/3. So this is x plus 1 by 3 whole square. This is something like method of completing square which you are doing from class 7 or 8. So this is going to be minus 1 plus 3 minus 4. See, I have converted this one, I mean plus 4 here because minus sign taken here. So this is 3 into x plus 1 by 3 whole square. This minus 2 by 3 whole square. You can easily use this form dx by under root x square plus x square. And no coefficient of x is there, we will treat this one as x only. 3 into x plus 1 by 3 whole square minus 2 by 3 whole square. So 1 by root 3 is outside. This is x square minus a square form. It will be log of x means x plus this plus under root x plus 1/3 whole square minus 1 by. You can simplify. You don't simplify, then also it's okay. So this way you can get the sums which is based on formula and standard integral. Okay. Now what I want to say, you never ignore these kind of sums. This looks like problem sums. Might be some of you have problem sum phobia, but I am telling you, for the sake of your board exam, you need to do this. Okay? So this is very easy terms you have learned in economics and commerce. So those terms only you are going to use, and the concept of indefinite integration as the reverse process of differentiation. Let me answer number 4 here. In sum number 4, marginal revenue is given and they are asking to find total revenue. This is ideal sum. In board paper you can expect. So marginal revenue is what? You know, if revenue is R, marginal revenue dr by dx. So dr by dx is 40 minus 10x square. So dr going to be equal to 40 minus 10x square dx. Now integrate both sides. This integration of dr is r. 40 integration of dx is x. 10 into x square is x cube by 3. And where does the integration constant go? It is there. And what is its value? As I told you, this will definitely represent a family of curves. But here, the value of c can be determined. Family of curves, you don't have to think here. This is a practical application, direct application of indefinite integration concept. That from marginal revenue, you are recovering the revenue function. Okay? If you go through the sum, it is given that the level of output total revenue is 120 at 3 unit of output. So output is x. So when x equal to 3, R is equal to 120. This is given. So this will help you to get the value of C from there. So 120 will be 120 minus 10 by 3 into 27 plus C. So the value of C going to be 90. So R, the revenue function, is found without C. C is now a known constant, its value is equal to 90. Alright? When X equal to 0, then R is equal to 90. So this much revenue we will always get even when no output is there. Okay? So all of you understand? Now let me discuss these two also in this context. Here marginal cost given. So you will apply the same method, put this is equal to dC by dx and get the value of C from there and use the initial condition given. Here it is given fixed cost 1000. What does it mean? After getting C, you will say that fixed cost means when X equal to 0, C equal to 1000. Sorry, when X equal to 0, C is equal to 1000. But this C is not integration constant. As C is given here as cost function here, we will be taking the integration constant as K over there. So this will give you the this information when X0 C equal to 1000 will tell you how to find the value of K, and you can easily get cost function from there. You try yourself. Again the sum is given, marginal cost given, cost of production C unit is 7800, find the cost. Same method. Compare this one with dC by dx and then find the value of C, and when X equal to C, put C is equal to 7800. You will get the cost function easily. Now we are in a position to revise this portion of indefinite integration, that is indefinite integration by partial fraction. What do you find there in indefinite integration by partial fraction? Here you will express the integrand as sum of two or more rational functions. Okay? You will express this one as two or more rational function. So when the integrand is of this form, you will be writing as a by x plus a, b by x plus b. If you take the LCM, you will get px plus q back in the numerator. But obviously when you are adding them, it is coming in the form of capital A and capital B. Then you go for comparison of two sides, two polynomials, left hand side one polynomial, right hand side another polynomial. You go on comparing and find the value of A and B and then integrate happily. Okay? For this one, what method already you have used in several sums. This is revision time. I am just telling you, if product of three factors there in the denominator, write it as sum of three rational functions. If one factor repeated, you will be writing this form, a by x plus a, b by x plus a whole square. If there is another factor with repetition, then you write 1 by x plus a, I mean a by x plus a, b by x plus b, and this is c by x plus b whole square. If there is a quadratic factor, this is x square plus b, then for quadratic you will be writing bx plus c at the top and then compare both sides. Let me apply this process of rational function, I mean partial fraction, to solve, to show you a few sums which you might have done from other books before this type. So I am going to show you one sum where some additional substitution concept also required. Let me do one part 2 here. What do you observe? It is x by x square plus 1, x square plus 2. Ordinary partial fraction can be used if you do it, or do it by substitution. Put x square equal to z. So 2x dx going to be equal to dz. So x dx will be dz by 2. This thing is dz by 2z plus 1, z plus 2. So half into dz by z plus 1, z plus 2. Alright. Now for this one z plus 1 and z plus 2, what to do here? We can use this form only, just a by x plus a plus b by x plus b. So for integration you write let 1 by z plus 1 into z plus 2 equal to a by z plus 1 plus b by z plus 2. There are two ways to find the values of a and b. I am showing you both one by one. So 1 equal to, you take it on the right side, a into z plus 2 plus b into z plus 1. A and b can be determined, as I told you, by two methods. Once by comparison, you write 1 equal to a plus b into z plus 2a plus b. There is no term containing z on left side, you can write 0 into z plus 1. So comparing, what will you get? A plus b is equal to 0. 2a plus b equal to 1. Subtract a1 and b is going to be equal to minus 1. So values of a and b are determined. So when you are going to integrate this one, then this integration easily you can write half into a by z plus 1, that is dz by z plus 1 minus dz by z minus 1. Integrate this thing happily and write the answer in terms of x. Z you must replace by x square. Then only the sum is completed. You understand? Now what to do for these kind of sums? Here you will be putting log x equal to z, factorize it and then use partial fraction. For this one, put e to the power x equal to z, change everything in terms of z and then use partial fraction. For this one, what to do? You write this as a by x minus 1 plus b by x minus 1 whole square, c by x plus 2 and then use the method I told you. But I was supposed to tell you the second method for evaluating the value of z here, that I forgot to tell you. I am telling you how to find the value of a and b without comparison. That also I would like to remind you. So when you have got this equation, you can start from here, this alternative method only, that you write 1 equal to a into z plus 1 plus b into z plus 1. No, a into z plus 2. 2 is there. A into z plus 2 plus b into z plus 1. So how do you do this? You put z equal to minus 1. Why z equal to minus 1? When you put z equal to minus 1, this becomes 0. This part will be 0 and from here you can get the value of a. So 1 is going to be a into now put another one, that put z is equal to minus 2. So if you put minus 2, then 1 will be equal to, this part is 0, b into minus 1. So b is minus 1. So same value we got. After this step, same method of integrating this thing. A by z plus 1, b by z plus 2, put a and b and then integrate. This method is common. Okay? You all understand? Now, how to integrate the other sums from this exercise? I mean, sum like this one. 5x plus 4 by x square minus 1x plus 2. Here is product of three factors. You will write a by x minus 1, b by x plus 1, c by x plus 2. But for number 9 and 10, what to do? To use partial fraction here, you need to do something there. You multiply numerator and denominator by x cube. This one is very, very special. Then it will be x4 into x4 minus 1. Can you see something over there? What will be the next step? You put x4 equal to z. So 4x cube dx equal to dz. So this is going to be 1/4 dz by z into z minus 1. Alright. This will write a by z, b by z minus 1, integrate term by term, and replace z by x to the power 4. Sum is done. Similarly, in number 10 also, you will multiply by x to the power n minus 1 numerator denominator and put x to the power n equal to z. And again, see the application part they always find. You will always find in their exercises. Marginal revenue given, so that marginal function is that. Ordinary integration, you will write this is equal to dr by dx and then integrate by substitution or by division, simplification, like that we will get. Similarly, another one given revenue function is like this. Find the total revenue function. This I can show you. dr by dx is given ab by x plus b whole square minus c. Therefore, dr will be what? Dx. Okay. Now you can integrate this thing easily. How to integrate? This a, b and c are constant. A, b, it will be x plus b to the power minus 2 dx. Minus c outside, only dx. So this will be x plus b to the power minus 2 plus 1 is minus 1. By minus 1 minus cx plus k. When c is already in use, you are integrating this also. So r is equal to this. When c is already there, you take integration constant as r only. Integration constant as k only. So r is going to be minus ab by x plus b minus cx plus k. This way, just after integration, you can find the value of r from there. Alright. Now in indefinite integration, part 3, this is not part 2. Part 2 I have discussed with you. Part 3 what to do. See. Integration by parts, always formula based. That integration of product of two functions is first into integration of second minus derivative of first, integration of second whole dx. That you know very well. Now, when you are doing that integration of this form, x into log x plus, let us start with this. How do we do it? For 1 part 2, it will be x into log of x square plus 1 dx. Now we will hesitate which one to take as first function, which one to take as second function. I would like to remember this concept, LAE. Okay? Logarithmic algebraic exponential. If you find product of, in the formula you have seen that there is product of two functions, then it is first into integration of second, like this. So this rule LAE, LAE, will help you to understand which one to be taken as first function, which one as the second function. The rule you can see that the integral of product of 2 is first into integral of second minus integral of product of derivative of first and integration of second. Let me explain. This LAE rule here. This one is a logarithmic function. This one is an algebraic function. Now, any two functions coming from there, the first one will be taken as first function, second one will be taken as second function. You take any two. If logarithmic algebraic is there, logarithmic will be first, algebraic will be second. If algebraic and exponential is there, algebraic will be first, exponential will be second. So in our sum, log x square plus 1 is the first one. Integration x dx minus integral of product of derivative of first. What is derivative of first? Log 1 by x square plus 1, you know very well, into 2x and integration of x dx is x square by 2 dx. You all understand? So I have used just integration by parts by taking log of x square plus 1 as the first function. So you take log x square plus 1, integration of x dx will be x square by 2 minus x square by x square plus 1 dx. Okay? One mistake NCERT has done, I'll tell you, and I change the sum accordingly. If it is x square plus 1, as I told you earlier, it will not be in your syllabus. So NCERT has done mistake here. This part will be minus sign. So I am changing minus accordingly, otherwise we won't be able to complete the integration here. I am writing this one minus. So this portion is minus. This one is also minus. This part is minus. This portion also. Okay. So to integrate the second part here, what to do? To integrate the second part here, we'll be writing it in the form log of mod you should use. Okay. Because log cannot be negative, log of negative quantity cannot be determined. This you write x square minus 1 plus 1 by x square minus 1 dx. Now can be done easily. It is x square by 2 log of x square minus 1 minus, now separate. It is dx minus dx by x square minus 1. So it will be x square by 2 log of x square minus 1 minus x, and this one is standard integral. You should remember this. Dx by x square minus a square. It is 1 by 2a log of by x plus a plus c. So this you write half log of x minus 1 by x plus 1 dx. The x plus 1 plus c. Done. So this is just by choosing the first function, second function concept you can get. Here log x first, x square second. Here x square first, e to the power x second. By using this Lai rule, logarithmic algebraic exponential you can get. Here log x whole square first and x second. You proceed, you can get. Another type of sum which is very important for your board examination, for applied mathematics students, I am telling you that integral is of the form e to the power x fx plus f dash x. This value is e to the power x into fx. So this is one line sum. You are recognizing yourself which one fx, which one f dash x, and writing the answer there. Done? No. If it is a 4-mark question or 3-mark question, whatever, then you cannot do it by this method. You have to find which one fx, which one f dash x, and then proceed accordingly. Alright? So for this one, here you need to find, let us start with the first one given here. It is e to the power x 1 by x square minus 2 by x cube dx. Alright? So in your board paper, you don't write the answer is e to the power x by x square plus c straightforward. Because you have used this form, this is given in our textbook, you have every right to use this, but you must show which one is fx and which one f dash x over there. So let me show it to you here what you are exactly going to do. Let fx equal to 1 by x square, x to the power minus 2. So f dash x is what? Derivative of this thing, minus 2x to the power minus 3. Answer is minus 2 by x cube. So then you write the answer, e to the power x by x square. No issue. It is done. Let me take another example here which doesn't look like e to the power x fx plus f dash x form, but it is actually shown. Number 1 done. Number 4 I am taking here. This is log of log x plus 1 by log x whole square. Apparently it seems that it has no link with the form e to the power x fx plus f dash x, but it is hidden over there. You make a substitution there, you will find easily what is there. You take log x equal to z. So x is going to be e to the power z, dx is e to the power z dz. Now change this one. So this is going to be log of, so this is log of log x, no, plus 1 by log x whole square. So log of z plus 1 by z square. This multiplied by e to the power z dz. Some insert has done some mistake. Log of log x will not be there. That then we cannot get the form of the form that e to the power x fx plus f dash x. Okay. So I tell you to leave this sum at this moment. It cannot be log of log x plus 1 by log x whole square form. It will be, I am telling you, 1 by log x plus 1 by log x whole square form. Okay. If you take 1 by log x plus 1 by log x whole square form or minus, then it can work. Okay. So this is being changed to 1 by z minus 1 by z square. This log x you have taken z, so this is 1 by z minus 1 by z square, and derivative of 1 by z equal to minus 1 by z square, it means it is of the form e to the power x into fx plus f dash x. So answer is going to be e to the power z into 1 by z plus c. You replace z by log x, e to the power log x by log x plus c is coming over there. Alright? So this way you can solve sums based on the concept of e to the power x fx plus f dash x. You need to show your parts of the function, which one fx and which one f dash x. Then you can easily use the form e to the power x fx plus f dash x.